Welcome to the stream. Welcome back. How is everybody feeling? Thanks so much, the Cyber Mentor, for the Twitch Prime already, and also Mokiros for the Tier 1 sub. Thanks so much. So, yeah, welcome back to the stream. Again, a little bit late in the day. I keep pushing it further and further back. I blame my sleep schedule since the Thugcrowd podcast. I'm again, like, everything is destroyed. I go to bed, like, in the morning at, like, 8 a.m. or something, and sleep in. It's not good. Oh yeah, I wear this shirt, so I guess I have to put the ad in the corner. Just kidding. I guess by German regulations, that's actually what I have to do, but I guess now everybody has seen it, and no, it's fine. I guess whatever. Yeah, welcome back. Sorry for pushing it later and later, but it is what it is. Yeah, we will see. So, first, at the start, I have 2 announcements to make. So let me switch to the laptop really quick. So, first of all, tomorrow, the Blind Hacker is doing a charity stream, and he has a couple of guests on, and I will also be on. So this will be from 3 p.m. EST. I will be on for an hour. Basically, I will just present this 8-bit computer project, and we chat a little bit, and I want to explain a little bit about electronics and how to get into it. So I don't know. I just want to make sure that you know that this is happening tomorrow. So check out the Blind Hacker on Twitch tomorrow. So that's the one event. And then I didn't open this. So today, in a couple of hours, the Google CTF will start. Oh no, they don't have a countdown here anymore. But yeah, so the Google CTF 2019 will start soon. Let's see. It will begin at midnight UTC. So that should be in like just over 3 hours, I think. So I will also play the CTF as much as I can. I have other stuff to do still. I also have the stream for the Blind Hacker tomorrow and stuff like this. Stop saying stuff like this. But I encourage you to check it out. They also have the Beginner's Quest with easier challenges. And I just ask you to just take maybe 1 hour, maybe 2 hours, maybe even 3 hours out of your day this weekend and just look at one challenge, maybe even 2 challenges. Try to stick maybe to a challenge that seems maybe possible, and just try to research, take notes, try as far as you can get, and make sure that you write down all the stuff you have figured out. Maybe even you solve something. That would be awesome. But even if you don't, then next week you will have the write-ups that people will create about the CTF, and we can even chat about it maybe on stream if you have further questions. Because I get to play CTFs not so much. I don't take so much time for CTFs anymore, but I will play this, and so we can have like a shared experience here. If you also want to play it, then we can chat about it. Oh, the beginner stuff has already started. Okay, I don't know. Whatever. Check it out. I mean, there's no rush. We all are not competing. We are just all want to learn. So do whenever. Yeah. So were there any questions? Can anyone register? Yeah, it's an open online CTF qualification. There will be, I believe, also finals, I guess, again. But yeah, it's mostly this is the online version. So what else? So these are the two announcements. I will mention them at the end or sometime later again. So today we will continue the build. I'm just curious. Basically, is everybody a returning follower, or is this the first time that you kind of see what we are doing here? Maybe if you are new, can you just put it like a 1 in chat or something? Then I know how much I should just quickly introduce the project again, or if you just should head right in and cut more wires. And I need to connect this charger here. Okay. I don't know how to parse a 5 and a 0. I run into a sec fault now. Yeah. Okay, so as you can see here, this is starting to take shape. This is a build. Not many people have written that they are new, so I won't waste too much time. We are following Ben Eater's YouTube channel on building an 8-bit computer, and we have already built the clock module. We have, wait, that's not the clock. This is the clock module. We have built the clock module. We have built 2 registers. These 2 are, crap, I changed them, sorry. This is the clock module. These 2 are registers. This is the ALU that can do addition and subtraction. This here is the 16 bytes of RAM. And this part here is a way to, by hand, select addresses for this RAM. And I believe what we will building today is another component that kind of belongs to this whole RAM setup, which allows us to select the 8-bit values that can be written into the RAM. The setup is like this because later when the CPU is executing, it will read from like a shared bus, read and write data to and from that shared bus. But we need to program it somehow, and you need to write those program bytes by hand into the RAM before you let the computer run. And to do that, you can switch into like manual mode, and then you can like select the addresses here, and then you are supposed with this other module set the byte actually that you are writing in that memory cell. And so this is like a circuitry for this in the middle is the RAM, and above and below is this kind of like control stuff that you can do this by hand. So fun stuff. We will cut a lot of wires, I think, today again. Yeah, I did not mine the silicon yourself. We are unfortunately not that much from scratch. Did Ben Eater? That is not a complete sentence. Sorry. What do you mean with finish it? So let's go to Ben Eater's YouTube channel again. We go to the playlists, and there's
so ever since I uploaded a few videos of this.
Here you also see a picture of how this will later look like when it's like complete, at least his version. And so we are already quite some videos in. So yesterday we watched part 2 of the RAM module, and today we will check out part 3. Okay. Do you have any questions before we head in? Are we writing a compiler? Probably not, just because the instruction set is extremely limited. We only have 16 bytes of RAM. So that is instruction, that is code and data in that RAM that you can use. So there's not much space. There's really not much a compiler can do. Any compiler constructs also would be way larger than anything like this. We also only have 2 registers. There is no stack, though. I mean, stack is not necessary to write a compiler for it, but yeah, it's just very limited. But we want to extend it maybe later, and so maybe this is like an option for later. But if anything, we will probably write an assembler. Maybe we will see. Maybe we also create an like an automatic programmer, not by hand, so you don't have to program it by hand, but maybe with an Arduino, so we can write programs on the laptop, and then use an Arduino to write everything into the RAM. That might be an option. Where will the code go? The data on the bus, but the code? No, the bus is there to exchange data between different components. So the RAM can output data onto the bus or can read data from the bus. And so the registers can read and write from the bus. The bus is just a shared memory lane that is used to exchange data between different components of this computer or CPU. The code and data lives in the same RAM. It's just memory, and like in your PC here, code and data is in the same, it just lives in RAM. But maybe we change that, there's an option that we could change that. Yeah. 16 by RAM, that's hideous, yeah. I adopt, yeah. Oh, there's one other project I discovered today. It's called, oh no, how is it called again? Let me quickly check. Oh no, where is it? It's called, give me 1 second. Oh yeah. Here, somebody made another kind of computer. This one is even more capable. It's called Gigatron. It also uses, as you can see, these kind of black chips. It lacks all the cool kind of like LEDs to be able to look at it. It doesn't have like a clock that you can execute like by hand. So it's already like kind of more integrated and a step up. But this one even has VGA output. So you can actually run their programs and have VGA out of it. The schematics are also all open source. You can download them, I believe. No, those are the slides. But they also sell a kit, so you can build that all yourself, or they also sell here like a kit. It costs like 150 euros or something. So yeah, I think that's also a pretty cool project. I've been also thinking about maybe building that afterwards also, but it's kind of a bit less, it's more exciting because of more output and input and VGA, and so it's a bit more complicated. However, it kind of lacks this coolness of seeing the values in the registers with LEDs and all these other things around that you can execute it by hand. This feels a bit more hands-on. However, I think it would be kind of cool once we finish this to look at this design. Then we understand all these different components and how a computer works, and so maybe we can then look into the design of this computer, and we should probably be able then to understand how this computer works and why this one is a bit more capable. So I think that would be really cool. Yeah, Dave from EV Blog and the 8-bit guy, they probably have covered these kind of projects for sure. If my math is correct, the Hello World program would have 6 bytes left for instructions. Yeah, I guess. I'm not actually sure if we could write like Hello World, because you have to imagine that the characters are already 10, and those are just the characters. So like what would a hello world mean? Maybe a hello world would mean that you push all the single letters one at a time into these registers, but that require, you have to put them in data and then read from that. So you need 10 bytes just for the characters and a bit more just to work on that data. Will we have a display? We have LEDs. They display value. So, but I believe there was like a 7-segment display. I think one of the registers can display its value as a 7-segment display, just like as a number. I think that's as far as we go here. But again, it's all, we are all free to extend this later. some other display method, maybe some kind of LED matrix, would all be cool, but all of that kind of requires also having more RAM. So one step at a time. Let's not dream too big already. Yeah. Is this going to be put in your closet, never to be seen again after you're done? I plan to hang it on the wall. I think it's like a pretty cool art piece kind of thing. If it like later turns on, I think it would look really cool. No, the stream is not sponsored by Coca-Cola. Give me a second. One second. Where do I found it? There we go. Fixed. What is Club Mate? Yeah, Club Mate is a German drink. It has a Wikipedia page. You can read it yourself. Do I have a Club Mate somewhere here on display? Or where did you get that from? No, I don't have Club Mate here right now. Perfect for just chatting. Poor shirt. Yeah. Okay. Yeah, I would say let's just get going. We don't have so much time left before the CTF starts. And we will be slow anyway, so here we go. Again, feel free to ask. Yeah. What's the plan for today? I believe we built the next module below here to, this was to select the addresses. Ah, crap. This module was here to select the addresses, and I believe we built the next module down here to select the values for the to write into the RAM. I believe that's the next video. The next video is called RAM Module Build Part 3.
So in the last video, we augmented our 16-byte RAM module with an address register, a 4-bit address register, that we can then switch between the address register and our programming mode, which allows us to set the address with these dip switches. And we can see the address here, and we can see the memory contents here. In this video, what I want to do is do something similar for the actual data that we're storing in memory. So right now, we have these 8 bits, which right now I've just connected down here to, looks like they're all set to 1s. But instead, we want to connect these to some sort of input that's either going to take the data to store off the bus, or take it from dip switches, so very similar to this. And so again, we're going to use the 74 LS157s to switch between the dip switches and the bus for the data that we're storing in memory. And so again, we want to give ourselves a little bit more room, so I'm going to use another breadboard here, and I'm going to connect it right here because we're going to do this right below here. Actually, I'm also going to connect below this the instruction register, which we built in a previous video.
Wait, we built an instruction register? No, we didn't.
We're not really going to be using the instruction register at all for this, but just when we put the final computer together, this is a good place for it. So we'll just have that there. So like I said, what we want is we want some dip switches here. When we're in programming mode, we'll be able to set the address here. We'll be able to set the data here to write data into memory. And that's how we get our program into memory before we actually start running things on the computer.
I know it's not quite required yet, but he said we built it in a previous episode, so at some point we have to build it. Yeah, but it looks, I guess, exactly the same as.
And then to switch between using the switches to program the computer and actually being able to let the computer put things in its memory on its own from the bus, we want to use those 74 LS157 chips that we looked at in the last video. So it has these A and B inputs and a Y output, and you select between A and B using this select.
Axel, maybe you can solve these challenges with the like this what is it called, Windows subsystem for Linux or something like this, WSL, like the Linux thing. Just basically press your Windows button and type in Ubuntu, and I believe it brings you to the App Store where it can install you like an Ubuntu shell, and then you should be able to do that stuff with it.
Pin here. Since we have 8 bits here instead of the 4, instead of using one of these chips, we'll need 2. And we'll start, of course, by hooking up the power and ground for each of these.
All right, let me also gather the things. Okay, so we will definitely build this, and if we are fast, we might even start with the instruction register, because that apparently also has to be done at some point. But we will see. So we have this. Okay, this fits perfectly down here. Excellent. Did the new, what is the new one? I don't know, but doesn't matter for these challenges, I would assume. Okay, and then we need the dip switch we have already here, and then we need the what was it?
These chips.
This was the 727, 157. 157. I was in the wrong line. What's the other? The 245? I forgot. Oh, this was the 173. So we need a 157 and 173. One 157 and 173. Got it here. LEDs I have here. They also use blue LEDs, so here are the blue ones. We need resistors probably. I believe those were might have been these here. No. Might have been these here. Well, we keep both here for now. Then we need one switch. When do you stream? Just saw your video. I'm streaming right now. I don't have a real schedule. I try to have this almost a daily thing now, though. Yeah, micro big music. If you type in, well, you know the project already. Too slow. Okay. You solved 4 beginner challenges of the Google CTF? What have you done now? I just got some parts. That's what I've. Or what do you mean? Or how far we are come? Well, in the top right screen on Twitch, top right, like there. This is our current build. So we've done the clock module, 2 registers, the ALU, the RAM, the address selection for the RAM, and we now are just now here on the value selection for the RAM. That's what we are doing. What we are doing now. Now it bothers me that Ben is not lining up the dip switch with the other dip switch.
And then just as we did up here, we have this pin 15, which is the strobe input connected to ground. And that's essentially just kind of an enable line for the whole chip. So whenever that's low, the chip is enabled. So I'll go ahead and connect pin 15 here to ground. And this one's going to be a little bit tricky because I have these LEDs in the way, but let me pull this out for a moment.
Oops, I'm connecting pins 14 and 15 on the second chip instead of 15 and 16, and I'll find out later when it doesn't work.
And we can kind of slide that in. And put the LED back in there, hopefully in the right place.
Oh, there's an instruction register video. Is that coming later? Maybe in the like, is the reason we haven't seen it yet because it comes later in this playlist? If it comes later in this playlist and so he describes it before we built it, then it's fine. Or did we just miss it?
Okay, so that's hooked up. And then next what I'm going to do is I'm going to connect the outputs. I've got 4 lines on each of these. So we have a total of 8 lines that we're selecting between either the dip switches or, well, it'll be the bus that we end up connecting into the B inputs here. But first I'll start with connecting the outputs of these into the data inputs of our memory, so that whichever source we're selecting from, the output is going to go into our memory. So we're writing that byte into memory. Okay, so I think that is everything. So I can pull these out. And now
Yeah, Ben is amazing.
All of the outputs of our selectors should be going to the data inputs of our memory. So we should be able to, well, once we hook up our dip switches and our bus, we should either be able to program the memory from the dip switches, or data coming in from the bus should be able to find its way into the memory. So now to hook up the dip switches, it's going to be very similar to what we did up here, which is we're going to be using the dip switches to connect the A inputs on both of these to ground when the switch is on. So for example, this will connect the A input of this first bit, or the sort of the most significant bit here, to ground when the switch is on. And of course, for that to work, I need to connect this side of it to ground. So when that's on, then it connects ground to that input, and then when it's off, it's disconnected, which means that the input's going to default to high, because all of the inputs on these have pull-up resistors built into these chips. If it's not connected, the input will be high. And again, just like we did here, because it's kind of unintuitive for the switch to be down, meaning high, and up, meaning 0. So down is a 1, up is a 0. I'm going to just flip this switch upside down, so that way when the switches are down, they're on, and then when we flip the switch up, the switch turns off. And so when it's off, it's not connected to ground, which means it's going to be a 1. And when it's on, when it's down, it is connected to ground, and it's a 0. So I'll go ahead and connect the rest of these. And of course, for these inputs up here, then I'll just connect them through the switch the other way, and connect the grounds down here, and then they just connect up into these pins up here rather than trying to run the wires back and forth.
I have maybe a color problem. Are these all blue? Because some of them look like a bit greenish.
Okay, and that should be connecting our dip switches up to the A inputs of the 74LS157s. Now the B inputs of the 74LS157s, so the A inputs are when we're in programming mode. So in programming mode, we set our address here, we set our data value here, and then we can write using this signal, and I'll hook up a push button for this in a moment. Use this signal to put whatever value we set here into the address that we set here, and that's how we program the computer. That's how we put data into the memory before we start the computer. When we go into run mode, then when we want to write data into the memory, it's going to be coming from the bus. and the bus, and then when we want to read data from memory, it goes out to the bus through these tri-state buffers. But to get data in from the bus, we want to bring that down into the B inputs of our 74LS157, our selectors here. So I'm going to go ahead and hook that up now.
No, that is clearly blue.
Okay, so that now connects the bus, which is going to be connected here on these 8 bits. That extends that bus into the selectors here. So that'll be the normal run mode. But then when we're in program mode, instead of reading data from the bus, we'll be reading data from our dip switches here. And so the way the programming will work is we'll switch over to program mode, set the address we want to program here, set the data that we want to put in that address here, and then we want to toggle our write. And of course, to do that, it would be nice to have a little push button switch. So I've got that here. Stick that in there. And so this will just be a little button that we can push to write the data. So once we put the address that we want to write it to and put the data here, push that button and it'll write it to there. But of course, again, we want to be able to switch between using this button to write to memory and the computer being able to have a control signal that's going to come from the control logic of the computer to tell it that we want to write data into the memory. So this write signal that's going into the memory now has to be switched depending on whether we're in program mode or not. So of course, to do that, we're going to use another 74LS157, which I'll put right here. So this write signal is going to come.
Thanks for the Twitch Prime, Hot Oreo.
Of one of the selectors in this 74LS157. Actually, I should have maybe connected our power here first. Get that underneath there. So power, and of course ground. And then again, pin 15 of this 74LS157 is essentially the enable signal. So if we want to set that low so that the chip is enabled, it's a low, active low signal there. So that's that. And so when we're in program mode, we want this push button to essentially take the program or the write signal here low whenever we push it. So we'll connect the switch from ground through the switch and then into the A input of our 74LS157. And so the A input is the input that we'll be using when we're in program mode. And then when we're in run mode, this is going to be a little bit different. In run mode, we want to essentially take the signal from the control logic. So the control logic in the computer, which we'll get to in future videos, at some point while programs are executing, it's going to say, hey, I want to write to memory. And so it'll set this write signal. But we don't want it to necessarily write immediately when the write signal gets set, because we want the write signal to say, okay, on the next clock cycle, we're going to write to memory. But then we want to wait for that clock cycle. So really, we want the write signal to be a combination of the write signal from the control logic as well as the clock signal, and actually specifically the rising edge of the clock. So what I'm going to do is essentially AND together using an AND gate the clock signal and the control signal saying that we want to write to memory. So I'm going to use a 74LS00, which actually is not an AND gate, it's a NAND gate. And the reason I want a NAND gate is because this is an active low. So a NAND gate is going to say when the write signal is high and the clock signal is high, then output is 0. And the 0 is the thing that tells the memory, the 74LS189s in this case, to actually take the data from the bus and write it. So first, let me hook up the power for the 74LS00, the NAND gate. We're just going to use one of the NAND gates on here. So the pin out is pin 1 and pin 2 are the inputs, and pin 3 is the output. So I'm going to hook pin 3 here over here to the B input of our selector. So hook that to the B input of our selector. So whenever this NAND gate is outputting a 0 and we're in run mode, then this selector will feed that 0 on through to the memory, and we'll end up writing whatever data is coming in. So one of these inputs is going to be the control signal that's coming from our control logic, which we'll touch on we'll build it in a future video and go into it. So when that's low, then we're not writing, and then if that goes high, then we will be writing something into memory. So we'll have that low. The other input is going to be from our clock. Go ahead and connect this up to our clock signal. Just kind of bring that back down here. And so this is saying when the clock is high and our write signal is high, then this goes low, which then is passed through. So I think we can go ahead and test this out and see what happens. So if we power it up.
Okay, cool. So let's get working. Oh my gosh. Okay, so let's see. Can I have a higher quality? Can't quite. Oh, why am I running this on 480? Now I can read the chips. So 157, 157. They are all 157. And then we have the NAND gate. So that is a 7400. Wait, the 7400, isn't that not just a regular AND gate? Didn't he say NAND gate in the video, or did I mishear? But we will check the schematic again as well, just to be sure. We also need to be, there's a lot of things we need to pay attention to now. Let's go to his website. RAM module. Oh, the 00 is an NAND gate. Well then, okay, all right, got that here. All right, okay. So let's see. So we are building. Wait, this is the full RAM module, is it? There's a push button. Memory address register. Okay. There we go. Okay, so let's do this. So we have put one here, then we need 3 175. I totally forgot what the 175 is, so let me check that myself again. So the 175 was that was the multiplexer. Fir, I know that you are not a new person asking this for the first time. I'm not falling for it. Okay, so let's see if we can line it up kind of like the other one. So that would be this switch here. And you could maybe align the dips. Wait, we need this chip. And then we need now the dip switch doesn't line up with the I'm kind of considering to switch their order to do it like this, basically. Then we have a bit more connections. Like it's a slightly longer path, I guess. But then we can have the dip switch aligned with the other dip switch. On the other hand, that we want to replace the RAM module at some point anyway, so maybe I shouldn't care so much. A slow start compared to yesterday? What you mean? Is this the most advanced electronics projects you've done? No, I wouldn't say so. I don't think so. I think the most advanced projects I've done was for the RHME2 CTF, the riskier hardware CTF that I've made videos about. This is fairly basics electronics. It's just a lot. All right. Oh wait, he uses not a regular switch, he uses a push button. I completely forgot. Just remembered that I had ordered these extremely long push button switches instead of the small ones, and now I'm contemplating, should I put the big one on there? It's actually maybe it's actually not too bad. Like you don't need to go so low down. That's pretty high though. Does this thing require any programming? Yeah, of course, it's a computer, and computers need programs to run. I'm not a Linux hardcore user, so my recommendation is probably not so much. I just use Ubuntu. I know a lot of people that play with just Arch or something. Stop saying or something. But yeah, I'm a very like basic person. I'm just happy with Ubuntu. I don't really care. So far, I've been able to run anything I needed to run on Ubuntu. So I don't really care much more about it. I also increasingly just use Docker for CTFs. So I use so I use the so I often play with my Mac, and so I'm just using Docker there, which is a VM in the end, but that's my way to run just some Linux, just to run something. In the end, I just needed to be able to execute stuff that has to be run on Linux. I don't really care about this OS itself so much. i3 is much more efficient than traditional window manager. Sure. Awesome is awesome, I guess. But those are not things that I particularly care about. Maybe I should, I don't know, but I don't know. Thanks for the tier 1 sub, Nakuzer. Okay, so let's put that in there, and let's put a button in here. Then we put the dip switch here, and then we put another 157 basically here next to it. And another one right next to it. I don't think I use conditioner. The solution of having a lot of hair is just not cutting it often. So we have 157, 157, 157, and the AND gate, the NAND gate. There. The clock speed, I don't know the max speed that will be possible, but our current clock module allows to go up to 500 Hertz. What is the best way to contribute and support your streams or YouTube? Absolutely love your videos and streams. You have taught me so much. Thank you so much. Thanks for the nice words. There's no really a best way to contribute. Your Twitch subscription is very appreciated. That is already more than I'm asking for. That's great. I try to offer different things like the Patreon, the YouTube membership, which is also a monthly thing, or now there's, I guess, Twitch. Those are, I guess, my direct main contribution things. They are options. I don't particularly favor one over the other. So that you support it on Twitch is perfectly awesome. What tier do we get photos of you through Patreon? My Snapchat is only for selected people. Okay. Oh gosh, I'm kind of dreading all the wire work now. Wait, what did Ben start again here? Okay, let's first connect the GND and VCC, I guess. This part is RAM, and these two parts around this are like kind of supporting the RAM, or are part of the RAM, I guess. They are also not theoretically not necessarily needed, but they help us for debugging and doing stuff by hand. Yeah. Will you do some Google CTF videos about it? Nope, absolutely no promises. I don't want to talk about like videos before I have done them. There's certainly like I'm thinking about it. Of course, it's like an option. It's obviously one of those things that I might do a video about. But if I find the time, or if like I think there's a good challenge to describe, will be things that I will know like afterwards. You know. If I make promises, then I just create pressure that I don't, and expectations that I don't want. So I rather have people not having any expectations than having expectations, and I'm gonna disappoint them. That's one thing that I don't like with content creators, or with some content creators, that they promise or advertise stuff that they haven't finished yet. So I try to have my stuff always done before I kind of like announce it, or I'm already like a couple of episodes in before I announce anything, just because I don't want to basically there's like this psychological thing about being rewarded. I mean, as somebody who makes videos, right, it's very rewarding to publish a video and to see the reactions and get the satisfaction of having a video done. But if you tell people that you are going to make a video, then that already gives you this satisfaction of this video, and then you are less likely to actually do it. Some motivation falls away, and so I'm very conscious of that, and I'm very careful with that. I find the JavaScript internals also confusing. Yeah, I have to. It's like not the. Yeah, same philosophy. If you tell your friends that you're making a project, you don't finish it. Absolutely. There's a name for this even. It's like a typical thing. And so every time when I see people announce fairly big and extensive projects, I see that, for example, with like, I don't know, like some people that want to make some games or so, then they show an early version of, or like their concept even just of this game, and tell everybody about it, hype it up, and then they never finish it. Or people announce like video series, and I've mentioned this before on stream. Ben Eder, in his first video where he introduces the project, he has not done any other video. He was just like announcing that he wants to make that, and I think that is way too brave. I would never do it that way. I think that so often just fails. So it's just some advice for anybody trying to do projects and stuff. It's so awesome to share projects and show things that you have done or you want to do. You are excited about them. You want to share them. I absolutely understand. But once you tell people, even a close friend or whatever, there's a good chance that already triggers a reward in your brain, and you are less, craving that reward now. Like the reward is basically gone. You got the reward already. You got that small shot of dopamine, and you are less likely then to actually do it in the end. So I feel like so there was one very early on Live Overflow. I made that by myself. I didn't tell any friends. I didn't tell anybody, no colleagues, nobody, because I was like scared of the reactions. I've mentioned this before, that I started Live Overflow doing it anonymously. As you probably know, like I have not shown my face and things like this early on. And that, I believe that also kind of has helped in a way to keep me going, because I was really doing it for myself, and I wasn't like announcing it beforehand or anything. I was just doing my videos, and when they released, they release. Yeah, so Ben either had the computer already done. I give you that. That certainly, I think that's a big, that's a a big reason why he was able to actually kind of finish it, because a big thing was already done, for sure. But yeah, still, generally it's something I'm very careful about. And it's really dangerous on stream because I have ideas all the time. I would love to tell you all the different ideas I'm having. I have constantly new ideas, and I even like start on them, but then but a lot of them I just abandon. And so I'm super excited. You know, I'm excited about these ideas. And now that I'm on stream and actually talking to people, I feel very. I really have to hold myself back. I've sometimes. Like even with the computer extension, for example, I cringe at myself that I tell you that I want to extend or add features to this computer, because I feel like that is already promising something and setting up expectations that I'm not sure if I can hold those. I want to, that is definitely the plan, but maybe it was a mistake to mention that. Maybe I should have be hard on let's finish this, and there's that. Want to finish a project, have no friends. I probably agree with that. And the AND chip, the NAND chip over there. How does this get power? And the NAND chip has VCC and G&D. Look at Intel, they can't even get the extensions right. Yeah, I mean, it's a different kind of extension, but yeah. Benita is an experienced tutor on Khan Academy. Yeah, for sure. So he has experience with creating educational content. So it wasn't like he knew what he was getting into. He knew the amount of work that goes into a video. So he didn't overestimate probably himself. That probably also added to why he was able to be successful with it. I also believe with when people announce projects or tech, I mean, everybody does this, right? Misjudging the time and effort a project will take. And so you're excited about it, you dream super big about that project, and then you get started, and then you have set all these expectations, and then you realize you can't actually do that. So let's see.
I'm going to connect the outputs. We've got 4 lines on each of these. So we have a total of 8 lines that we're selecting between either the dip switches or, it'll be the bus that we end up connecting into.
Finding chunks of wire insulation scattered everywhere for months. Actually, I've been, because of stream, so usually, you know, I don't pick up after myself all the time. Usually I have a pretty messy office, I would say. Because I'm in here all day, basically. But because of stream, I need to make sure that the space looks kind of presentable. So every time before the stream or even right after the stream, I pick up all the little pieces, I put all the components away, I like pick up stuff from the floor or vacuum really quick. So streaming has been very good for the clean state of my office so far.
To the B inputs here. But first I'll start with connecting the outputs of these into the data inputs of our memory, so that whichever source we're selecting from, the output is going to go into our memory. So we're
I mean, not quite. Wait, what is he doing now? This looks insane, like the cool kind of insane. Do you ever have problems with connections with that much breadboarding? What do you mean with problems with connections? So I mean, so far like no connection has failed. Also, like all the breadboard connections so far have been seem to have been just working. We all know that cleaned up workbenches are a lie. Well, start streaming, then you might feel the pressure to pick up after yourself. The dog is visiting. Hey, dog. Hey, dog. Come here. Okay, he doesn't care. He goes to sleep down there. I don't know. Did you see his tail or something? Come here. Say hi to chat. Say hi to chat. Might have to start streaming. My room is a mess. I'm telling you, there are good incentive things that help you with these things, right? Writing a blog post or doing videos helps you to organize your own work and helps you to build a resume and a portfolio. And streaming helps you to keep a clean apartment. We don't know what breed this is. That is like a street dog with everything in it.
We're writing that byte into memory.
Okay, so what is he connecting there? So, kind of forgot what all these cables are here. So wait, so these were the data in, right? The green ones were the data in. So we are now connecting the data in stuff, right? So, for example, what is the first wire he's changing?
On each of these, we have a total of 8 lines that we're selecting between either the dip switches or, well, it'll be the bus that we end up connecting into the B inputs here. But first, I'll start with connecting the outputs of these into the data.
Okay, yeah, okay. So he puts them just up there to get them out of the way, and then he attaches them to the outputs here. So we just, I guess, look up the outputs of these chips.
Inputs of our memory, so that.
But now I'm curious here. So wait, which one is he connecting here? Is this the lowest bit? The lowest bit, I guess. And the lowest bit goes in this chip. Oh, I need to look up this chip again. So this. So this, the lowest bit is Y3. Okay, then let's do this. So this connection here, our connections are a little bit reversed than Ben Eater's. We figured it out last time. I connected them in a little bit weird order, but these ones are now in the correct order, like these LEDs, if I remember correctly, hopefully. So basically we just need to make sure that we are following this pin out. So this green wire here, this should be our lowest bit, so this should be Y3. Is that correct? Can somebody confirm that this is correct? Program streaming a couple of times. Oh yeah, that sucks. I'm not making too many assumptions, but since I have connected the Ethernet and just not use Wi-Fi, stuff has been a lot more stable. How can you execute programs with this computer? Well, it's a computer, and a computer by definition can execute programs. So does that explain how it executes program? But in detail, if you are curious, we don't actually know yet. We are building this right now. We don't know all the details yet. I can tell you that we have here several components that you can find basically in any computer. Up there's the clock. We have here registers. This is the arithmetic unit that can do addition and subtraction, and this will be the memory RAM where the instructions will be. But how exactly these instructions will be executed, these will be in future parts that we haven't started with yet. If you are interested in the whole I mean, you have already used your Twitch Prime, so you must have been here before, right? So you know what it is about. So just follow Ben Eder's video. No, I guess I'm confusing the symbol. Never mind. But yeah, so it's based on a video series. If you're curious how exactly this works, you can check out Ben Eder's series on it. We are following that right now. Yeah, we are just building a computer, and a computer executes instructions. And we are here to learn how a computer does that, basically. We don't really know yet ourselves. Okay, so I'm a bit annoyed at our color choice of wires. So all the way over here on the register, we used green wires. And here we use blue wires that will later be connected to the bus. So the blue wires are the input for the bus. And now over here, we have done everything in blue. And once we connect the wires for the bus, Ben also connects blue wires, but those are actually blue. And so now it annoys me. I feel like these should have been green, and then we should have used blue for the bus connection. And now the color is inconsistent, and this is annoying the hell out of me right now. I'm like really torn right now if we rip out all these cables and do them in green again. But I shouldn't, right? I shouldn't. This is the RAM module anyway that we want to redo, right? Like we want to get rid of that RAM module anyway. That's quite a lot of wires. Let's leave it, whatever. Paint the wires. Yeah. I guess let's just continue with blue. That all the, well then, okay, then let's say the RAM is blue. Okay, the RAM is blue, and then we do the bus connections in green, just so we can kind of see the separation. Maybe does that make sense? I don't know. Hey dog, are you now want to say hello? Come, you want to say hello? Come up here. Do I have food for you here? No, I don't think so. Come here. Come here. Come here, Frida. Come here. Come here. Come here. Come here. Yeah, walk to me. Walk to me. Walk to me. He totally wants it. Yeah. Yeah. Yes, it's a he. Okay, so we go from here now all the way up there. So like this, then we go like this, and then a bit more. Here's a street dog too. Nice. Your dog looks exactly like yours. That's awesome. Do you have a picture to share? These street dog looks just so much cuter than any terrible breed dogs. You think they look alike, but you had 480p. Right. So then I guess we can like bend here. And then we go, then we bend here. Shiba Inus. Yeah, I also thought about getting a Shiba Inu because they also look so damn cute. But then we decided not to get a breed dog, but get a rescue dog. And then we plug it in here. I see, you see fog right here? Yeah, I think I start to have a few. Oh my gosh, getting so old. In my makeup tutorial, I think you can also see a receding hairline. I'm still not 100% sure if it is a receding hairline or not, but it could be. I'm just glad that you don't see dandruff on my hair. Okay, wait, we need to count wires. 1, 2, 3, 4, 5, 6, 7, 8, 9 wires. Wow. No, we are not soldering those wires. These are breadboards, so you can stick in those wires. That's what those breadboards are for. They are prototyping boards where you can stick in components and connect them. So you could, for example, like prototype a small circuit that you want to build, and you can make sure that it works. And when it works, then you can manufacture the PCB and order the PCB online. It's like a PCB just with plastic. Not sure name, Sam, if you have seen this yet. Oh. Ah, crap, this doesn't work. And then here. Ah, crap. Oh, my battery is empty here. Oh my gosh, this is a whole disaster. Okay, so why? Wait, why? Wait, what? I didn't look at the outputs. Y3 is not the first bit. I guess Benita didn't connect it in order. Y4 over here is... Oh, no. I'm just contemplating right now. How did we do this on the other registers over there? Like, those chips are numbered, right? The input. So you can see there's like A1, A2, or in our case we are looking for Y1, Y2, Y3, Y4. And now we have these things in order here. How do we count? 1, 2, 3, 4, 1, 2, 3, 4, or do we 1, 2, 3, 4, 1, 2, 3, 4? How do we count? Oh, it does look like my dog. I guess let's do 1, 2, 3, 4. This means this connection here, we have to shorten it just by a tiny bit because we go to the 11th pin, which would then be right here in the middle. Wait, is this the correct chip? Wait, this is not the correct chip. Oh no, I'm looking at the wrong chip. Oh no, I closed chat. Does it matter as long as you connect them to the right LEDs? Yes, exactly. That's the thing, right? You wanna, if you constantly mix and match your orders, then you need to constantly remember this. But if you keep one consistent system, then every time when you look at the board, you know exactly, okay, this is the system I've been using, and it's consistent throughout the board. And now we start, I think in the RAM module, we started to kind of screw that up. So now this doesn't, like, this is not matching anymore, and now we need to always be very careful. Okay, so this is the correct one. Okay, still kind of correct though with what is like Y3 and Y4. We also need to connect G and D for these other ones here. Okay, but let's shorten this really quick. So the Y4 output is here. Okay, fixed. So that's, I would say we put this then up here, so we know we done that one. Okay, so this was the first one. So now we have basically 1, 2, 3, 4, 1, 2, 3, 4. We started now with the fourth output is the lowest light. You have no idea what's going on. I mean, it's simple right now. We are following a series, right? It looks very complex as a whole what is going on here, but these things were all built step by step and well explained by Ben Eder. So yes, overall it looks complex, broken down in single parts. I'm sure you can understand it too. So don't worry about it too much. And what we are doing right now is again, might look kind of crazy because you have maybe never done this yourself, but it's really simple. Like, this is a chip here. This chip has pins, and what you can see all the way there at the top, this pin out. This shows the pinouts of these chips, and you can all see like these lines going in, and so these are the different pins of this chip. And essentially, what we are doing right now, we connect the output of these chips to the input of the other chips that we have here. And so I'm looking at this image up there, and I'm looking for the outputs, and the outputs are labeled. It says output on there. So there's Y1, Y2, Y3, and Y4 as outputs. And so I'm just connecting these now in order. We know the inputs here from last stream, and the inputs have these cables on here. So we know exactly that this here was the first input, and so we connected it to one of the outputs here. And so I'm now going to the next one. So the next output is this one here. That's Y3, all the way at the bottom right, basically, or top right, I guess, if you look on the chip like that. Usually you look at the chip vertically. Anyway, all the way top right, here's output Y3. So I connect this to the next wire. The next wire in order is this one here. So it goes all the way up there. So we need to now make a cable from this output to this input up there. So that's all we are doing now. So, and then I'm always looking back at how Ben Eder has connected this, just to kind of like see what are the expectations or something like that. I don't know. Can you move the board without disturbing the connections? Like they are like all together, or what you mean? So these are prototype breadboards that you can stick together. So these are stuck together, and this is stuck together, and this is just like hanging off there. This is not connected, but yeah. And yeah, with a complex system like this, right? It's like the key is just breaking down it in smaller, understandable parts. Like as a whole, it's really difficult to conceptualize or imagine it. But if you just go here step by step slowly, you could also totally do that. We are just following a baking recipe at this point, basically. Adding wires. I did add wires. We haven't added more wires since last time. So this output, and you know, most time that we are spending here is just like making it kind of look nice. So I plugged it in here, and now I'm kind of want to make sure I make the bend like at a good position here. Going up here, and then we make like here another bend. Who do you usually watch on Twitch? I go through phases, so sometimes, you know, I just am in a certain phase, so so that stuff can constantly change. But as of right now, the streams I'm watching the most is very kind of like trendy right now, like nothing special. Miskiv and Maya. Miskiv is just so good at streaming. It's just so funny. And then Maya tried to explain Twitch her sister yesterday, and that was pretty funny. We can see all the details. That is an amazing camera then. You should add decoupling caps. Oh, we have one up here. Is enough? No, just, I don't know. Yeah, we need to add more at some point. You wonder what I'm doing? I'm just bending cables. Wires. Oh, crap. Yeah, I'm sorry. This is like, I don't know, I need to lean over to look at the stuff. Maybe if I do it like here. Alright, yeah, I need to pay it more attention. Chill dude, do you think the offensive security penetration testing with Kali course is worth it? That totally depends on your situation. It's completely unique. It's not something that you can generically answer to say if it's good for you. That totally depends on your situation. I have, that's the only certification I have, but I also got it paid for by the company I was working at. So they had like a budget for certifications, and I did that. No, I don't think necessarily root beer tastes like medicine. I mean, there are some root beers that taste a little bit like too strong, I guess. But yeah. Do you plan doing JIT exploitation stream? Again, I've never streamed JIT exploitation. It's not something I can do, actually. Also not sure what you would stream there. Okay, so now we look for the Y2 input, which is down here. How does spin either wire the bottom ones all the way up? Oh, he goes all the way over there and goes up. All right. But yeah, on Sunday, the next video in the browser exploitation series is obviously coming out. I need to register my casino. What are you? I'm gonna ban or time you out for saying stupid stuff like this. What book do you recommend someone who wants to pursue security? Check out oh shit, it's not getting started. Where was it? Start hacking. There you go. Those are basically my thoughts on the topic. I've never learned with books, so basically no clue what kind of books to recommend. So the next one goes down here. But Childo, do you have a little bit of experience with like programming, like you know, just some background, or are you complete zero? Uh, Pretty much, yeah. Some of them contain a little bit more. So, for example, the 555 chip up here contains also some resistors. I believe actually these chips that we are working on right now might. No, maybe they not. But we use some flip-flops or registers that contain also, I think, a capacitor maybe. But essentially, yes. And actually, I don't think that they are CMOS. I think, or are they CMOS? Maybe. They are the LS chips, so like the old school. I mean, maybe internally they use now CMOS. I don't know, but were they not traditionally transistors? But don't ask me. I'm a bit of a noob too. Okay, so this one here, so we go right there. Is that working better out with my hair right now? And do you recommend CCNA and CCNAS? I have no clue what they contain. Not even sure I've heard of them. But I assume, are you from the US? Because I also think that industry is a little bit different in different countries, and I try to, I mean, like if I would notice that I couldn't get jobs without certifications, I also would get certifications. But I feel like I would hope that they realize that I know stuff without having those certifications. I mean, like I personally would do certifications if they help me for like understanding something, to learn something. So depending, for example, OSCP, I did that when I was at university working for a company and had very minimal knowledge. So this was a great learning opportunity for me, having basically know nothing and going in there with basically out any experience. So that was awesome. I learned a lot from that stuff. But yeah. You're a network specialist. I'm from Cisco. Oh, all right. Okay. So yeah. So I guess then. So you are already like a professional in some field. Then maybe certifications make sense to like prove for being able to transition, I guess. You probably don't want to look for like like take a pay cut and go back into some entry level position to show that you can do it, and so you want to have already some experience that they pay normally for, kind of deal, I guess. Yeah, then maybe makes sense. Oh, you're from Morocco. Okay, no clue about the industry in Morocco or how that works. Uh, yeah, I think the best advice I can give with all these kind of certification regards and industry and working would be to look for people in your country or even your city. Look them up like on LinkedIn. Maybe you know them through colleagues, and ask them about their experience in the industry you are going to. So if I would, for example, want to go to the US to work there, for example, let's say I want to go to California or something, then I would not ask some Germans, what do you think about certifications? Because that doesn't matter. I would try to find people that are there, that know, that understand that environment. So I can only give you very minimal experience from my side being in Germany, and also from my, I'm young, right? I'm only working as a freelancer. I have no experience with the rest of the German industry. I have somewhat of an idea, I guess, from talking to friends and having heard of other kind of jobs, but I could only give you a little bit of, I guess, advice in our country, but anything else I couldn't. You would have to find somebody local to you, I think. Atom Fighter. To be honest with you, I don't remember exactly those like extreme low level details. I think Ben Eder in his series has covered them again. We are kind of, so to say, like one level kind of above that. We are using the ICs that implement already those logic things on a defined level, like on like 5 volts, and it's all like properly kind of like set. So we are working, I guess, one layer kind of up. I use the word friends a bit loosely. You know, friend somebody on Facebook or on Reddit and ask them. Okay, so we've done this cable. Maybe I should also keep them in order. So now this one here goes from Y4 okay, thanks for the clarification, Shildud. Then I don't know. I had fun with OCP. Like I said, I came in with like I had a programming background. I understood a lot of basics, but it was fun. It's a CTF that costs money. Not really CTF. It's a fun lab, right? It's actually not as structured as you might hope for, because you are saying that you don't like it scattered. At least from my time, I mean, I did it when it was still Kali. No, wait, now it's called Kali. I did it when it was Backtrack, PWB, penetration testing with Backtrack. So my course material is obviously way older than the current one. However, I've talked to somebody recently. It looks like that the course material actually hasn't much changed. I feel like that has also come a little bit of an increase in criticism, that it's a bit old now, but old material in general. But I wouldn't necessarily be bothered by that too much. It's teaching you stuff that is still maybe it's directly not applicable, but kind of like the methodology and all this kind of mindset around it and stuff that's changed. Anyway, the course itself isn't really structured. You get basically just thrown a couple of kind of like basically a book where it's a little bit structured, but then basically you get thrown into that lab environment and you are supposed to basically self-study everything. The course material just holds your hand for a little bit, but throws you then into a lab where, yeah, like I said, you're supposed to self-study everything. Their mantra is to try harder. It's part of the course basically that you are researching yourself and you need to do yourself. So you get a bit of hand holding with the course material, and you have a lab, so you have dedicated challenge machines that you can try on, but that's about it. I think that's enough of a framework to help you not feel scattered, but maybe you are looking for an actual more kind of course, then it's maybe not it. Yeah, so for example, like I said, it was fun. If you have disposable money and you don't really care about it, yeah, just, I don't know, buy it, I don't care. But to be honest with you, I'm a bit biased here. I also feel like you can learn more about security when you watch my videos. I feel like, I mean, you are lacking kind of the exams, and so that's kind of the self-study part. You have to go out and play the CTFs and challenges yourself. But in that sense, maybe, yeah, I don't know. I, yeah, I would hope my videos help more, and they are free. And yeah, it sounds generally also with your background, I just recommend you to play some CTF. In a couple of hours, the Google CTF, in like 1.5 hours or so, the Google CTF starts. I just recommend you to just dive in, just try out start with the beginner challenges, and if they are good for you, if you learn stuff, then keep doing those beginner challenges. If they are too easy, then try some harder ones. And then you then basically maybe fail, and then later you look at write-ups and you learn from that. Maybe we even discuss some of these challenges on stream, like on Monday or so, or maybe Sunday, Monday probably. That again is like not structured. It's a bit self-studying, but yeah, I know that's how I learned. So, like I said, I did it when it was backtrack. I only had the 30-day thing. I didn't get all the machines. I thought like the exam itself, that all stuff was easy. There was certainly hard machines, and a lot of machines I couldn't get. But the exam and the I felt that was super easy. I don't stream on YouTube, really. Only if it's like kind of something really live overflow related. I don't really have a schedule yet. Usually a bit earlier than how I started today. I generally would want to be over with streaming by this time now, but my sleep schedule is screwed up, so it's kind of this now. Oh, I cannot give you any university advice because I've only been to one. Uh, I don't think that this university is particularly special. I have gone there for different reasons. However, I would encourage you to check out Bochum. If it, I went to Berlin for other reasons, but if it would have been completely me, I might have gone to Bochum. But in the end, it really doesn't matter. I would actually select it based, like, if you are set on Berlin for some reasons because you want to be in Berlin, it's this capital city, maybe other friends go there, you feel like, you want to, yeah, things like that, then university can be very stressful. And I believe that in any university you will learn a lot. Doesn't really matter. I think it's more important that you surround yourself, with good study groups, find good people, use a lot of opportunities, and Berlin offers a lot, right? So maybe that's why Berlin is great. But Bochum is as far as I know, is very hard and has produced a lot of great people. Most of my colleagues are actually from Bochum, so. Chill dude, if you do your masters, usually you don't need to know German. Yeah, ETH Zurich is also great, of course. Berlin, to be honest, is nothing. I'm at the technical university, is nothing really special. I enjoyed the security courses there. I'm doing a regular computer science degree. Um, I don't know. Yeah. But I also didn't do my bachelor's here. I'm here for my master's, so I can't speak for how the bachelor is. Bochum has a great CTF community. Berlin also has a CTF community, but these things also change, with each year because old students go away. So that's also hard to predict how it will be when you start. Uh, Limb skin, basically that's how they are structured, but that's kind of a recommendation thing. I'm like in my 4th year of my master's now, I think. So that is like the recommended study time. Oh, you need visa. Oh, god damn it, I hate borders so much. Okay, so this goes in here. Oh, I guess here. Do we need to have more space there for something? I don't think it matters, right? My battery is charged. Did somebody hear the high-pitched noise again? That was because the battery is charged. If you hear it and it annoys you, feel free to say it. I might not notice it right away. 0.1 wire per minute, not bad. You want to see how far you want to move? I encourage you to move away from where you're from. It has been one of my best choices. I was also kind of worried about like moving away from where I grew up, but it has been honestly one of the best choices to like broaden my horizon. Okay, so this goes all the way up there, and then we go. We make a bend here. We have a regular study time of like 3 years for bachelor and 2 years for master, but and I did my bachelor because it was also a different kind of program in those 3 years. But for my masters, I'm like in my 4th year, I believe. So I guess overall it's theoretically 5. Xele, did I get this correctly that you are living in Berlin, or? Or this is where you're from or something? Oh, you live very close to Bochum. Ah. The unit is teasing, but I can't go. Why can't you go? Oh, a school decree too bad to join the uni. Makes me so furious. Hate our system. hybrid machine. What music genre do you prefer? I don't really have genres. I just listen to Spotify recommendation. However, I do feel fondly for example, drum and bass. I connect a lot of hacking sessions with that, so that's like a go-to genre when I want to get into like the mood. Yeah, I don't like summers either. I also prefer just like cold or rainy weather. Yeah, we have like a mobile AC unit. Super inefficient and all that yada yada, but oh my gosh, the cold air is so nice. Here's actually like a, let me see if I can show that somehow. Like this hose here is connected to a mobile AC unit in the other room. So you don't have to hear the noise, but I can get a bit of cold air. Chill, dude, that sounds awful. But don't you live with AC all the time? Does your country not have ACs everywhere? Considering converting it into a PCB, it's definitely one of these ideas that we maybe could do. I believe other people maybe even have done so. I haven't seen the project so far, but I feel like somebody must have tried. But yeah, it's one of these things that we could do. Not sure yet how I feel like if we will do it or not, but it's definitely a possible project. Okay, I kind of like how I did the wiring there. I think that looks pretty good. So here, these connections. Okay, I will be AFK for just like 5 minutes or so. Just refilling my drink and eating a small snack, and then I will be right back. Sellout hackers taking over again. Thanks for playing. Sorry. I was eating so fast, but it took longer than I thought. Okay, cool. So we have these connections done. So what is next? Oh my gosh. At the start of the stream, I was dreaming about finishing this module and then even maybe doing the instruction register. But now I just hope we even finish this this module, half of it. No, that is called La Metric. It's an overpriced product every YouTuber owns. It's like one of these requirements that you have by YouTube before you are allowed to get the silver play button.
Our program into memory before we actually start running things on the computer. And then to switch between using the switches to program the computer and actually being able to let the computer put things in its memory on its own from the bus, we want to use those 74LS157 chips that we looked at in the last video. So it has these A and B inputs and a Y output, and you select between A and B and select pin here. Since we have 8 bits here instead of the 4, instead of using one of these chips, we'll need 2. And we'll start, of course, by hooking up the power and ground for each of these chips. And then just as we did up here, we have...
Okay, let's add a G&D here really quick. I mean, it's an LED matrix, basically. It has some colorful LEDs to the left to display like some kind of logo, and then some white LEDs to display some text right next to it. What's the point of it? It's a display. It looks pretty neat. You pay for the design, you don't pay for, yeah. It's also like pretty cool LEDs. It's like square LEDs, you know. It's a decorative item. People pay $200 for paintings or even more. Some people pay $200 for a stupid blinking light. I don't really see that one of these things is superior than the other things. Oh yeah, I don't think that it... No, it has nothing to do with Google. There was a joke. It's a joke because every YouTuber like buys that and puts it in the background. It's not by Google. It was a joke that it's a requirement for for large channels or something. It was just a joke. It might have been a Kickstarter or something. Let's see. There you go. It was a Kickstarter at some point. So, did they split up the cost? What it will... I saw DIY projects for them. Yes, of course, there are DIY projects. I don't understand why this is so surprising or difficult. It does look clean. It's a non-standard thing, right? It's like weird squared LEDs that look really nice in a nice package, built by a small company that raised money on Kickstarter. People have to be paid. Designs have to be paid. Then the manufacturing of some kind of weird non-standard thing has to be paid. The whole software has to be implemented, right? It's expensive, sure. And then of course you have also all the manufacturing at scale. If every stupid kid would buy this, then you could manufacture it way cheaper, but the demand is not that high, so it's more like a premium product, right? Because the demand is just not as high, so you have to make it more expensive because you can't manufacture at that crazy scale. You know, it's not manufactured by Sony and placed into every store. All these things contribute obviously to a bit higher price, and then in the end, you decide if you want to buy it or not. And of course, you can't build your own. But I'm lazy, and I think it looks neat. And yes, it's expensive, absolutely. But don't Kickstarters usually like split up their costs as well, like how they intend to use the money? I'm kind of curious. It doesn't look. I didn't see it now right away. Maybe they have it linked somewhere, kind of hidden. What is the cost? No cost. Okay. I mean, it has been out for quite a while, and you know, this is from 2014. Estimated delivery 2014. So this Kickstarter has been from before August 2014. So 5 years ago almost. This Kickstarter old. Okay, there's just no yeah, and I'm sure maybe on Alibaba if you look for I don't know. Well, let's check. Let's see. But then I'm also sure like it's not the same kind of build quality and it doesn't work with the app. Okay, that didn't quite work out. I shouldn't search probably on Alibaba for weird stuff. There might be weird pictures coming up. Yeah, I don't know. Some things in life just cost money, you know. You don't need it. It's absolutely consumer luxury product. Some people buy submarines, you know, for recreational use. Some people buy yachts, and I buy a stupid LED display. Actually, I meant to go to AliExpress, but I completely like my brain fried. But yeah, you can look yourself. There's also the other YouTuber thing that everybody knows is the crap, what's it called? The triangle lights. I forgot the name. Nanoleaf. Here, the Nanoleafs. They are also expensive as hell, but they look just really, really nice. So here, like a starter pack, you know, just some lights like this, 350 euros. A few more lights, 550 euros. That small starter thing here, 250 euros. They look really, really cool. They are a unique product. There are some knockoff versions, but they just get it really nice with the features and how it looks. Yeah, if not every YouTuber had it, I would have it all over my wall there because I think it looks really cool. But it's kind of like you get judged by it. You get judged for it. That's what I meant to say. Oh, wrong button. Just grab some. You know, are you trolling? I can't tell. Just grab some RGB LEDs and just use a 3D printer and just use some acrylic. Like, you understand how many hours and stuff this involves, things I've never used before, the upfront cost for a 3D printer, and then also money you pay for things that go wrong because you don't do it perfectly the first time or so. Not to mention the hours and hours that go into it, which is totally fine, you know, it might be your fun project, but it's not, it's absolutely great as a project, but you cannot compare just buying it on Amazon with making it yourself. You know, you make it yourself because you want to make it yourself, and not because you want to save money. Always put Winky Smiler Kappa behind your thing. Okay, I'm glad. Sometimes I get YouTube comments like in the same vein that I'm not sure if they are not serious. Just buy $1,500 worth of materials to make $300 worth of product. Yesterday, I made an Excel spreadsheet, or like a Google spreadsheet, whatever, just to check the cost of the stream so far, because since I started streaming, who has been here early knows that I basically every day I had stuff delivered and I upgrade the whole streaming setup. You don't really like see this, but like these arms, this arm for the overhead camera, the light, the FLIR camera, like so much stuff I bought, and the parts of course itself as well, plus some parts to experiment with. And I'm guilty of ordering even more parts again. Oh, gosh, I hate myself so much. Overall, I've spent so far 2,000 euros in the past week. Yeah, it didn't feel that much until I put it onto that spreadsheet. Oh. Other people buy a yacht, as you said. You don't have a partner to go what? Well, it's my money. It's actually the money of the Live Overflow business. It's like the money that is coming in from YouTube and Twitch basically, and Patreon. So the money I'm getting is well reinvested. Yeah, business expense. Oh man. The stream gear will pay for itself over time. Well, you have to imagine that I also have to put my time into streaming, and so far, you have to understand, I do this all as a hobby. I have another main job, right? This is not my main job, and it can't be my main job because of what I earn. Of course, I get here and there a little bit of money, and that accumulates to a nice amount that allows me to pay for gadgets like I did now here for the stream. But you don't have to forget that I also have to put my work time into this. And while, yes, there's this small amounts always trickling in that accumulate to something, if I would break that down to like an hourly wage, I'm working here at, way below minimum wage. And it's obviously not even close to, it's not even close to minimum wage, so it's very far away to a salary or the hourly wage of somebody who hasn't, a university degree. So it's not, I'm not in it for the money here right now, right? Or let's say, I hope, of course, at some point I get filthy rich off this. That would be cool. But my main motivation cannot be money, of course. Otherwise I wouldn't do it. Oh, I'm not counting the electricity bill. That makes it even worse. Yeah, but I'm having fun, exactly. It's fun, I'm learning. There are many benefits beyond to this kind of stuff beyond money. Luckily, I have another job. Luckily, I have something that gives me money that allows me to do something like this as a hobby. A hobby that helps to pay for itself cannot be a bad thing. Correct. I just have to be very careful to not make it a second job. And Live Overflow has somewhat become a second job. I put a lot of time and stress into it somehow. This is a good point. I need to be careful that it doesn't become a second job and that it remains a hobby, that I remain in control. Yeah. one of these reasons that I don't offer much for Patreon, for example, because if I really offer perks for Patreon, that means I'm obligated, I'm expected to deliver something and work for something, right? That's why I have to constantly tell that I don't offer really anything, and all these other things, right? It has to remain a hobby, otherwise it would be bad. You should have become a pro Fortnite player instead. Well, if I was good at Fortnite, for sure. But unfortunately, I'm not good. You know, it's not easy to be good at this game.
Have this pin 15, which is the strobe input, connected to ground.
And
that's essentially just kind of an enable line for the whole chip. So whenever that's low, the chip is enabled. So I'll go ahead and connect pin 15 here to ground. And this one's going to be
weird about it?
Tricky because I have these.
Oh, I play Apex a lot too. I play way too much Apex.
Pull this out for a moment.
And I'm an idiot. The first season ended just before I got the epic lock, the level of 110. I was so mad at myself. I thought this first season would go exactly before second season starts, but then it was over.
And we can kind of slide that in. And put the LED back.
The concept of making millions a year playing video games still mess with my head. Why? These people that are that successful and make that much money, they are working their ass off. Do you really like to play Fortnite 8 hours a day or even more? Or even just every day a couple of hours? Every day, no matter how you feel, you always have to deliver and perform that and be an entertainer on stream. Come on, this is not easy money. And you have to be good at it, you need to stay concentrated. If you keep just losing, then people will not watch you anymore. Don't underestimate it. I have huge respect for any of these streamers on Twitch right now that have like 10k viewers or more. They are working their ass off.
Back in there, hopefully in the right place. Okay, so that's hooked up. And then next what I'm going to do is I'm going to connect the outputs. We've got 4 lines on each of these. We have a total of 8 lines that we're selecting between either the dip switches or, it'll be the bus that we end up connecting into the B inputs here. But first I'll start with connecting the outputs of these into the data inputs of our memory, so that whichever source we're selecting from, the output is going to go into our memory. So we're writing that byte into memory.
Okay, we got that. Oh wait, no, we forgot. Wait. Oh right, we didn't do these. Okay, so wait. We did these. But we need 2 more. I thought we were done. God damn it. Do you know the vid isn't on your screen? No, now I know, thanks. It's the same vid that we have been watching. I just noticed that I forgot 2 more wires here. Yeah. Like this, up here, and then we go over there. Ready for Google CTF? Yeah, kinda. Looking forward to it. Are you ready? Is this becoming night shift overflow? Yeah. I have been all week already screwed up my sleep schedule. So which one was which pin here again? So this is 2. Where are you from, Milo? Oh, US, yeah. Uh, Ghidra has a decompiler. But I'm also not a professional in any of these tools, right? I'm very much an amateur. So I use whatever I know how to use and I can use to solve. And Ghidra just fulfills a lot of the just does everything and has a decompiler. So that's extremely useful for me as a noob. Yeah, I didn't have it installed. It's not like I have like your well prepared setups all the time. I didn't know what the challenge was gonna be, right? I made sure that I have a Linux machine ready just in case, but I didn't know what it was. If it was like web or reversing or exploitation or whatever it might be. And then I read the article and started, and then I realized, oh, it's like a Linux binary, or we might need to reverse engineer it. And then I realized, oh, I'm on the laptop where I didn't have downloaded Ghidra. So that's how it is. What do you mean by ready for the Google CTF? Like I'm existing. I'm alive. I have a laptop and I have internet. That sounds ready to me. Habit code. So who of you is going to have a look at the Google CTF? Can you like write the one in chat? I'm doing the beginner currently. Oh, that's awesome. How's it going at Narek? If I remember, you have just like a web development background, right? Is this like your first CTF that you are trying out, or did you have some experience before? Thanks, thanks for the tier 1 sub, Bitcode. There's no way I finish any of the challenges though by judging. Yeah, it's gonna be tough. I will also be happy if I solve a challenge. But it if you solve it or not doesn't matter, I think, at least to me. I hope I make good progress. I hope I kind of understand what's going on. That's like the main challenge for me. And then if I solve it or not is not that important, because we can always look at the write-ups. I just hope that, you know, I make at least some decent progress. That's kind of the importance for me. You won some time ago and went to DEF CON with it? Oh, you have a master in cybersecurity? Oh, I'm so sorry. I somehow connected you to web development. I guess just because you were hanging around on the web development stream. All right then. Okay. Why are you doing the beginner challenges? Or are you just doing them because you are waiting for the real challenges to open up? Oh no. Okay, I caused a small problem. No, I'm not sure what I did. Okay, so if you so here I've always like the cables that I was done, they were all plugged in here in the bottom. Always when I connected them, I put them up here just to be sure. And now I was reaching the last two cables, the last two green cables that are connected right here. These two cables that are connected right here. And so I connected this blue wire, and if you look where this blue wire ends, it ends right here, so on this cable. But this cable is still plugged in on this side, which means this is the one I should be doing now, because the other one here I moved back here, which means I indicated it's done. And so now the problem is this connection correct and I moved the wrong wire? Or did I connect the wrong wire and I should have gone to the other pin over there? And I don't know this now. C5A1, you're gonna have to trace it and see when it's supposed to go. Good job, a real 5-head. Very intelligent. Yes, I know. The problem is this is all screwed up already. I don't know the order of the pins. This is what we had discussed earlier about, it doesn't really make sense anymore. Oh, god damn it. Okay, let's do this. Probe it with the meter doesn't really help me here much. Okay, so let's think. This cable here, if this is the input for this C189 chip, yeah, then I believe this should be the output. This output goes over here. This should be the output, and this goes up here, which means it goes to this LED, which is the second last LED. Second last LED. Oh, that seems then correct. So when so this cable here so if we would connect wait yeah, so if this is the output for this cable goes in here, then this is the output going over there, and that's the first. Okay, that means I just switched those things. Okay, this was less complicated than I thought it would be. I take it back, sorry, as if I've but yeah, Captain Obvious. Okay, this worked out. This was easier than I thought. So we didn't connect it wrong. So this goes all the way over here. Oh wow, Bitcode. Thanks so much for the 5 gifted subs. And look at these 2 Germans that got a gifted sub. Teppich Reini and Profilüfter. Yeah, thank you so much. That was very generous. All right. Okay, so now we have it hooked up. So now we can move this over here. Whew. Is there only one icon? Yes, so far. I'm not sure. Can I add more already? So I don't have any prepared right now, but we already got an idea for a white rabbit. A white rabbit is another good emote. But if you have more ideas, because I don't really have ideas actually. Last time I checked, we only had one emote available, so let me see. Oh, I can add 5 now. So I can add actually 4 new ones. Yeah, I have overall now 5 available, so I can make 4 more. But yeah, I don't really have ideas. So like a white rabbit is a really good idea, but yeah. Yeah. A doggo one. Oh yeah, Frito could be one. Bitcoin. So you have you done like this before? Because I'm happy to commission and pay you for artwork, of course. Like if you have, if like, yeah, feel free to send me like your contact me on mail or Twitch, Twitter or something, and send me like your portfolio, like some examples or so what you've done. No, I'm paying for this. I refuse that people work for free. Like one that prints your name or something. Wait, what? Oh, that's awesome. Yeah, send me some stuff. Cool. That sounds great. I'm happy to spend money on stuff like that. Awesome. Yeah, again, and if somebody has Frito is a good idea, I guess, and White Rabbit is a good idea. But yeah, I guess we still have two more. We could maybe do a chip, like an IC chip. I'm sure that doesn't really exist on Twitch yet. But it should also be, an emote should also kind of be like a reaction to something. So I wonder, maybe like blinking, like a LED that's turned on and an LED that's turned off or something. Then you can spam like blinking LEDs. Like in, whatever. I don't know. We need a wire. Yeah, I don't know how, if a wire would look good on like as an emote, because like so thin. Also, at some point maybe we are done with electronics and you have to watch me play Apex. Then I'm not so sure. Me with sunglasses. If you have got more emotes, just a 3-part wire. A 3-part wire? Oh! Now I get it. Dividing up and using 3 emotes as one long wire. Yeah, think about it. Not so sure about the doggo though. I guess, but that's actually a good reactionary one, I guess. Okay, let's continue the video.
Okay, so I think that is everything. So I can pull these out. And now all of the outputs of our selectors should be going to the data inputs of our memory. So we should be able to, well, once we hook up our dip switches and our bus, we should either be able to program the memory from the dip switches, or data coming in from the bus should be able to find its way into the memory. So now to hook up the dip switches, it's going to be very similar to what we did up here, which is we're going to be using the dip switches to connect the A inputs on both of these to.
1 second, sorry. Okay, sorry.
To ground when the switch is on. So for example, this will connect the A input of this first bit, or the sort of the most significant bit here, to ground when the switch is on. And of course, for that to work, I need to connect this side of it to ground. So when that's on, then it connects ground to that input, and then when it's off, it's disconnected, which means that the input's going to default to high because all of the inputs on these have pull-up resistors built into these chips. If it's not connected, the input will be high.
Doing good,
and again, just like we did here, because it's kind of unintuitive for the switch to be down, meaning high, and up, meaning 0. So down is a 1, up is a 0. I'm going to just flip this switch upside down, so that way when the switches are down, they're on, and then when we flip the switch up, the switch turns off. And so when it's off, it's not connected to ground, which means it's going to be a 1. And when it's on, when it's down, it is connected to ground, and it's a 0. So I'll go ahead and connect the rest of these.
Okay, now let's connect that as well. For that we need this chip again to see where the inputs is, and he has connected now to the A inputs, so we do this too. Okay, so I guess we start maybe, no, we can start at the front, I guess. So we need, so the first was up here. The first, so this here should be the first, the 8 here. Okay. So this goes in here, and then this would go over to here. "30 minutes to the CTF. Looks so cool here. I think this looks so nice, like these wires that make that like climb over other stuff. Doesn't this get you like back into like the time when you were a child and you watched these movies where like cartoons would go inside of computers, and then you have the data highways or something, and these large cities of inside of computers? This is what this reminds me of. Makes me feel really fuzzy. Wait. This is completely wrong connection. Wait. This LED over here, what did we say? Shit. Does anybody remember? So, god damn it. Oh my gosh. Why did I not write this down? Okay, so wait, let me think. We talked about these outputs like Y1, Y2, Y3, Y4. What did we say Y4 is? Is Y4 the very first LED? Like this? Is this Y4, or was Y4 this? Was it like Y1, Y2, Y3, Y4? Or was it Y4, Y3, Y2, Y1? Oh my gosh. Okay, so wait. This is Y4. This cable goes all the way up here. And this is the all the way to the right. Okay. So this should be pin number 1. So this was way too long. So this goes to pin number 1. Have you done long-term project with Raspberry Pi? No, I've never had the use for a Raspberry Pi really as a long-term project. Wait, there's one project I can tell you about in a second, but for anything like long-running in a way that you say here server or service, I'm just usually just renting like a DigitalOcean server. So then I have a public IP. I don't need to worry about my IP at home changing. I don't need to worry about a lot of things. However, I was working on one project a while ago, which was almost functional, but I never pushed it to the working state. So at the time we had rats as pets, and they are active at night, and so I was building using the Raspberry Pi camera module, and used infrared LEDs to have like night vision for the camera, and then the camera would like detect movement in the inside of the cage, and would record the rats, and then would automatically upload those videos to YouTube, so you as like private, and then you can like later watch your rats being active at night. And it had some issues, so it was kind of working and kind of not. It was not working well enough to actually use it. The general features were there, but like I said, yeah. So that's like something I did at some point, but yeah. Oh, Mr. J, you're working on an LCD screen to my computer now. Wow, that sounds awesome. Very curious to see that. Will you then also document it properly, like on Reddit or something? So, and this one is now pin 2. Wait, what the heck am I doing? These are the outputs. This is Y. I need to connect them to the A, to the input. So it's this Y output, Y4, then 2 over here, then this here. It has to go in there. My gosh. I think slowly I'm reaching the mental capacity for this project for me. You need to update the other Reddit post though, since I've now finished my yeah, make a new post. That would be cool. I'm not sure if you were here earlier, but I've placed another order. I've ordered more parts from Mauser, like a proper like press button, different potentiometer, and I hope and blue flat LEDs. I hope that they are good now. That they fit better onto this build. Also ordered like different RAM, a couple of different RAM modules, because I'm not sure which one to use yet. If I do your method or the method some other people have used. Yeah. I'm also not sure if I should change the architecture to have like a separate like code RAM and data RAM to basically win a few, just like win more space through that. But I'm not sure if that's how easy it is. As you know, I don't know exactly this computer yet. What like how easy something like that would be. You just need a lot of modifications, you think? That's quite curious. Like in my head, it sounds so simple. In my head, like based on my limited understanding of this computer right now, I feel like I just have to add like another of these microcodes, like another feature to read it from that RAM or that RAM, and and then all the instruction fetching is done from that one thing, and all the other instructions just operate on the other RAM. That feels simple, like that in my imagination that seems super simple, but obviously you are the only one with experience right now here. I still don't understand how that works. You saw the POC or GTFO, the Bible, you mean the Bible book? That means you, if or do you just mean me recommending it in general somewhere? Yeah, it's hard lecture, I guess. Self-modifying programs are half of the fun, though. I guess. Or even more RAM, like have an address register, kind of like AVR. Use two registers uh, as an address. Maybe even 16-bit instruction pointer. I don't know. A lot of things we could play around with. Okay, so now this goes from... Okay, so now these are connected here, which means I have to put two ground connections down there. Oh, I haven't updated wires at all. Crap, how many did we add? It's simple, but you need more control lines, and currently there's a limit of 16. After 16, you need to rewrite the EEPROM code and use a third EEPROM. That's why it just ran into try to send us even. Ah, interesting. Good that I ordered like one more EEPROM, I guess. 15 minutes to the CTF. Okay, God, I don't think in 15 minutes I managed to connect the other 6 cables. Kind of would like a few minutes before the CTF starts to connect with my teammates too. Okay, so this output here. No, wait. The input. I have to go to the input. So this is the input that goes to 3. I thought you weren't playing with team this time. Didn't I say like I don't know if we are playing or what the deal is? But looks like some people are playing from our team. So here's like one problem I have with streaming and generally interacting with people. My views and opinions and everything constantly change, and I worry so much. I express some thoughts or views that I have not fully thought out in the moment, but or just have changed, or the context was different, or all these kind of things. And so now expressing so many of my views and whatever opinions, and then they are not correct anymore, but in people's heads that's the view that they have about me, and that's really bothering me. I even like maybe 5 years from now, there will always be a couple of people who might watch these recordings, and then they think that I have a certain, like, that I'm a certain way, and I have completely changed also since then. It's really bothering me, that thought. That's why sometimes I think I should play a crazy character on stream, so just that I can always claim I'm just playing a character. LRWR, I misread your message. You wrote, "Don't be hypercritical. Feel free to express your ideas." And I read it as, "Don't be hypocritical. Feel free to express your ideas." And I was thinking, no, like, that's the thing. It's all the time hypocritical. Contradicting my views and everything. Oh wait, the 64 number is the flags, not control lines. Wait, what? The separate RAM modules are called Harvard, actually, while the combined RAM is called from just some knowledge drop. Actually, we have thought, I mean, yes, I kind of know, but if you look, if you don't, we didn't really explore this on stream last time, just a little bit. But let's have a look again, because I feel like there's also difference in how the buses are arranged. So, can you show me please English results? So see, don't in the Harvard architecture have all the different, the data memory and the instruction memory, crap, have their own buses and connections? Isn't that Harvard architecture? While the von Neumann architecture has a shared bus for the memory unit? Or is that picture disconnected from how the buses are set up? And so if you have a shared bus but different memories for different things, isn't that then kind of like a mix between the two? But I'm not sure. We talked about this on stream the other day. These definitions make kind of sense to talk about, but in the end, in reality, everything might be a bit more fluid than we might think it is. How about, yeah, it's a mix of both, I think. Yeah, I think so too. Just to drop some knowledge. Okay, so now we need to count the wires. We have added at least 4, but I think we have added more, right? Okay, wait, overall, 19 we are now. Okay, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The add wire alert is when we are adding wires to our build to count how many wires we have added. Okay, so now we have 4. Okay, we connected 4. So now we need the 2 ground lines up there. More so, yeah, but yeah, I generally agree with you. Like that's my personal belief as well. But I mean, that's unfortunately that's not how most of people in society works. Time to move out of just chatting. Yeah. I'm too fast right now. I'm just too efficient with this work. Okay, so we added the first 4. Okay, so the CTF starts in 5 minutes. I think I will end the stream now, so that I mean, until everything is wrapped up on my side, the CTF will basically start. So let me remind you that the Google CTF will be starting now. There are also beginner challenges, so if you haven't played CTF before, definitely check out the beginner challenges. They are available right now already. Otherwise, check out the challenges that will be released in just any moment. I cannot stream the CTF, of course. It's a competition. That doesn't make any sense. Yeah, so check it out. Look at some challenges. Try them out. Take notes. See how far you can get. And when the CTF is over, check out the the write-ups, and we can maybe also have a chat about if you get stuck and you don't understand something, you are happy to ask the next time we are then streaming after the CTF, and then we can maybe talk about it. I will not record everything I mean, I can record it, but I won't release it because there will be private messages, emails, and all that stuff that is on my computer while I play CTF. Will you make videos about it for YouTube? It's definitely an option, but no promises at all. It totally depends on what kind of challenges are there, if I solve them, what my experience is, and if I have time to make the videos, if I feel motivated. There are many ifs, and so I cannot promise anything. You all hope to see my process. There are plenty of CTF write-ups on my channel to see my process. Yeah. All right. So yeah, it would be really cool. It would really cool if you try. Just take a couple of hours this weekend, maybe even 1 hour only or so, and look at 1 or 2 challenges, maybe see how far you can get, take notes, and then later look at the write-ups. And again, on Monday or so, or next week when I'm streaming, feel free to share your experience with me. And also, if you have questions or certain write-ups are not clear to you and you don't understand them, maybe we can figure it out together on chat, you know? So I think this could be like a cool stream experience as well, where we can then interact after the CTF together and share a little bit what things that we have learned, sharing good write-ups that we found, or even the write-ups maybe you write yourself. I think it would be pretty cool. It's midnight UTC, so I don't know where you live. You need to change. So this is basically 2 a.m. for me now. When is the next stream? Oh yeah, by the way, tomorrow the Blind Hacker has a charity stream, and I will be on there as a guest at 3 p.m. EST. I will probably start streaming a little bit before that on on twitch.tv/liveoverflow on here, and then I will be dropped into that call. I will do that hour stream, and then maybe stream a bit afterwards again. But again, I mean, mainly want to focus on the CTF also tomorrow. But yeah, so there will be a short stream, I guess, tomorrow. Nothing special though. I basically want to talk about the 8-bit computer, explain a little bit the basics of electronics, just, you know, and have a little bit of chat with chat. Yeah, so there's a charity stream tomorrow, so check that out. It's by the Blind Hacker. Does he have his Twitch linked here? It's not directly linked here, so I don't know. But his name is also the Blind Hacker on Twitch. Jeez, you are up late. I hope you're not tired. My sleep schedule is completely effed up right now. I went to bed this morning at like 8 a.m. or so, and I woke up at like 2 p.m. So I will now. So it's like just middle of the day for me. Okay, thanks so much. The CTF is almost starting. I wish you good luck. I think it would be really great if you check it out. Thanks so again for hanging out with me. Thanks so much for all the subs that I got today, and especially Bitcode for all the gifted subs that you have given out. Yeah, thank you so much, and good luck to you all. See you hopefully tomorrow. Bye bye.